So, today we're going to be talking about the different parts of an atom and showing those different parts in an atomic model, similar to ones we have learned about in the history of the atom. The one I'm going to be having you guys draw is more similar to Bohr's model than the current model we use, which is the wave model, just because this depicts and shows everything a little bit more clearly. So by the end of the lesson, you should be able to draw a model of an atom and show its different parts and calculate all of its different pieces. All right, so I thought this was important to add because sometimes naming the elements isn't easy just by their symbols. So I have provided you with a periodic table. It should be closer to the top of this week's module. So we're just going to go through and identify a couple of these elements and talk about their symbols and where they come from. So P, this is for phosphorus. Ni, this is for nickel. If you remember back in mixtures, compounds, and elements, we talked about the symbol and how if it had two letters, the first letter would be uppercase and the second would be lowercase. That's because it's coming from the name here, and we typically uppercase the first letter of a pronoun or a name. So the third one we have there is Cu. This stands for copper. If you notice, there is no U in the copper name right there. That is because these symbols come from the Latin name. And we don't use these typically much anymore. The reason they were given symbols for their Latin names is because when the periodic table was created, which we will talk about next week, they used the Latin names for all the elements. Nowadays, we use the English, and it is so much easier just to leave the symbols as they are and know that they come from their Latin names than to spend years upon years changing all the periodic tables so that the symbols correctly match. So we've got CO there, that would be cobalt. Br, this is bromine. K, this is potassium, something you get out of your bananas every day. Na, sodium, this is half of your sodium chloride table salt. Fe, that is iron. All right, so now we're going to talk about the atomic theory and more of the model portion of it. So we've already discussed the atom a little bit, but I wanted to reiterate it just so that it was in the forefront of your mind, because we're going to be drawing models of the atom. So if you remember, the atom is the smallest piece of an element, and it is still retaining the element's properties, its physical properties, and its chemical properties. So one thing that we know is that you can't see an atom with your plain eyes. Whether you have glasses or not, you cannot see an atom. So they have been too small to study. But with advances in science over these many centuries, we have been getting a better idea of how they look and how they work. So if you think back to last week when we talked about the history of the atom, you remember Democritus's model and how it was basically just a circle. You didn't see any detail. There was no identification between electrons, protons, and neutrons. There was no showing of a nucleus or energy levels. That's because there wasn't advances in science. He had no tools to find out this information. And then if you remember, as years went along and more studies happened, the models started to look more advanced, all the way up to our current model, the wave model. So we're going to talk about 3 different parts of the atom, and I'm sure you have talked about these before, but I'm going to probably give you a little bit more detail than you may have learned in the past. So the 3 different parts are the protons, neutrons, and electrons. And as we have learned, there is a nucleus in these atoms, and inside that nucleus we have protons and neutrons. And something you may not have known, the nucleus makes up 99% of the mass of an atom. So electrons take up 1% of that mass. That is because electrons' mass is so tiny that it's basically irrelevant. We don't typically worry about calculating the mass of electrons. If you get into more advanced science classes, they may have you do this, but for our purposes, we are going to pretend that the electrons have no mass at all, and we're going to pretend that the nucleus makes up 100% of the mass of the atom. Alright, so the first part of the atom that we're going to talk about right now is the protons. If you notice, I do have a symbol indicated for that. It is going to be a lowercase p with a plus sign, so this just allows me to shorthand. So the charge of a proton is positive, hence the plus sign here. If you want to think about it in a different way to help you remember, protons are positive. If you think about your pros and cons list that you create when you're making a huge decision in life, your pros list is the positive things about this huge decision. Maybe it's buying 30 12-packs of pop. You're writing a pro list for this to figure out, you know what, are those 30 12-packs of pop worth it? So the positives, the pros. So think about it as pros are positive. And we've already talked about the location of the protons. This is inside the nucleus. One thing to note here, we've talked about the fact that we're going to pretend instead of 99%, the nucleus takes up 100% of the mass. So the protons take up half of that 100%. So the protons equal 50% of the mass of the atom. Okay, and a way to figure out how many protons are in each atom is looking at the atomic number. So if you're taking a look at the periodic table that I've provided you or one you found online, typically the atomic number is going to be in the top of the box of any of the elements that you're looking at, and it's going to be bolded. So if we're looking at boron, the symbol for boron is B. The atomic number is 5. So that would mean that there are 5 protons in a boron atom. So the atomic number is equal to the number of protons. All right, the next thing we're going to do is do an example. So, how many protons are in the element Al? If you don't know what Al is, this is aluminum. Okay, and aluminum has the atomic number of 13. Atomic number equals 13. All right, and like we have stated in the previous slide, the number of protons equals the atomic number. So saying that, that means that my number of protons is 13. So aluminum has 13 protons in it. All right, now let's talk about neutrons. The symbol for neutrons is going to be N, and I do not have a charge indication. That is because neutrons do not have a charge. They take up space, they have a mass, but they have no charge. And like we've talked about, they are located inside the nucleus. So this is the other half of the mass of the atom. Because remember, we said that the nucleus is going to be 100% of the mass of the atom, and we stated that protons were already 50% of that mass. So this means that this is the other 50% of the mass of the atom. All right, and in order to figure out how many neutrons are in an atom, we have to take the mass of the atom. So on the periodic table, it's going to be the fairly long number, at least probably 2 to 3 decimal places, and that is going to be the mass we are going to use. So we are going to take the mass number, subtracting the atomic number to equal the number of neutrons. Remember, the neutrons and the protons make up the mass of the atom, so that is why we use the atomic number, because we're given the mass of the atom, we know how many protons are in there, so that just leaves us to figure out how many neutrons there are. All right, so let's do an example. My favorite thing in the world. All right, so how many neutrons are in Al? Remember, Al is aluminum. The atomic number for aluminum is 13, and we've already figured out that that means there's 13 protons. Okay, so we need to figure out the mass. So the mass on the periodic table states it is 26.982. So we just want to use whole numbers. So we're going to round this up to 27. All right, so now to calculate the number of neutrons, I'm going to use a different color. We need to take the mass number, which is 27, subtracted the number of protons, which is 13. So that gives us 14 neutrons. All right, the next and last part of the atom we're going to be talking about is the electron. And I have symboled this with an E minus. It does have a charge indication. That minus means that the charge is negative. So the location of the electrons, we know that they are not in the nucleus. So that means they're outside the nucleus in this nifty thing called the electron cloud. It's like a cloud of negatively charged atoms, or negatively charged parts of an atom, I apologize. So again, we've stated that this has very little mass. And so for our purpose, we're just going to pretend that it has no mass, because otherwise it starts to get really finicky when it comes to calculations. In order to figure out how many electrons are in an atom, we will take a look at the protons. So if we have a neutral atom, or what I like to call a happy atom, because neutral, who doesn't like to be happy when they're neutral? So if we have a neutral atom, that means the number of electrons is going to equal the atomic number, or the number of protons. Another way to figure this out is looking at the electron configuration, and that is something that you will learn in chemistry down the road. So neutral atom, electrons equal protons. Let's write that. I want to write this in a cool color. Electrons equal protons. There you go.